Hello everyone. I welcome you all for today's session. In this session, I am going to discuss about Brinell hardness test. Before going into today's experiment, I express my sincere thanks to Virtual Lab developed by Ministry of Education under the National Mission on Education through ICT, and also our sincere thanks to NITK, IITs and NITs. Now, today let us start today's experiment. Okay. The name of the experiment is Brinell's hardness test. The objective of this test is to determine the indentation hardness of mild steel, cast iron, brass, aluminum, etc. using Brinell hardness testing machine. Apparatus used in this study is Brinell's hardness testing machine, as you can see in the diagram here. Now, before starting the test, first we have to select the specimen. For that, we are going to do the Brinell's hardness test. Here I am selecting cast iron, which is having a diameter of the indenter. Here it is 10 mm. I am selecting cast iron for my test. Okay. When you selected cast iron for your test, load to be applied is 3000 kg. This is the standard data. If you are selecting brass, copper or bronze, load to be applied is 1000 kg. And if you are selecting aluminum, magnesium or zinc, load to be applied is 500 kg. Depending upon the material, we have to choose the load to be applied. I will move on to the next step. This is actually called as Brinell's hardness testing machine. Here you have to keep your specimen here. After placing the specimen, there is a hand wheel you can see here. You have to rotate this hand wheel such that when the gap between the surface of the specimen and indenter is 5 mm. Let us rotate this hand wheel. Okay, now let us assume the gap between this indenter and this specimen will be around 5 mm. Let us proceed with the next step. Okay, now we have to switch on the motor and we have to keep on applying the load for 10 to 15 seconds. So I will switch on the motor and I will unload it. Okay, now I'm applying the load and I will apply up to 15 seconds. Now I will close the lever and I will move on to the next step. In the next step, by using this by using the hand lever and back into the unload position, the diameter of the impression is measured through microscope provided in this machine. Here you can see the microscope will see like this, and you have to rotate for the adjustment to see the exact diameter of the indenter, and you can see measured diameter is 5.9 mm. Okay, and let us move on to the next step. In the next step, this is the calculation we have to do. Material selected is cast iron. Diameter of indenter is 10 mm. Load applied is 3000 kg. And diameter of indentation, horizontally it is 5.9 and also vertically it is 5.9. You just take the average of that. It will be equal to 5.9. Calculate D by D ratio, that will be equal to 0.59. And finally, Brinell's hardness number, we are going to get it as 99.21. That is called as HBW. That HBW is calculated by using the formula 2p divided by pi into d into d minus square root of d square minus small d square, where p stands for load, capital D stands for diameter of the indenter, and small d is the indentation what we obtained in the test. We have to repeat the same steps for another trial. So I will just move on the hand wheel. I will make a gap of 5 mm and I will move to the next step and I will switch on the motor here and I will release the load. So I have to apply load for 15 seconds. Once 15 seconds is over, just unlock the load, move to the next step, and by using microscope again see the diameter exactly, and that will be equal to now 5.73 mm. Let us move to the next step, do the same calculation and find out average value to find out HBW in terms of kg per mm square. And this is how you need to conduct Brinell's hardness test. Thank you guys. We will meet in the next session with another experiment.